Secure Boot was supposed to keep us safe. It was supposed to be like a bouncer for your computer that makes sure only the right guest, in this case legitimate software, is able to make its way in. But the latest UEFI malware is like that hot chick that your Secure Boot bouncer just can't say no to. So it slips right in like it owns the place, and it can compromise your computer even across operating system resets. This particular vulnerability was found in a UEFI application called Reloader.efi, which is signed by Microsoft's third-party certificate and is a part of several system recovery programs, including Howier's sysreturn, Greenware GreenGuard, Radix Smart Recovery, and many more. This custom PE loader doesn't use the standard load image and start image UEFI functions, and as a result, the application allows the loading of any UEFI binary, even an unsigned one, regardless of the UEFI secure boot state. Now, normally the way things work is when a UEFI boot manager proceeds to load a boot application, such as Grub or the Windows Boot Manager, it verifies that boot application binary against two secure boot databases called DB and DBX. The initial database contains a list of certificates for software that's allowed to run on your system, and this list gets preloaded by your computer's manufacturer and oftentimes includes certificates for Microsoft software so that things like Windows are able to boot on them without any issues. DBX, on the other hand, is a database which contains a list of revoked certificates. Oftentimes, these certificates were once legitimate, but got replaced with new ones, like the Microsoft Corporation UEFI CA 2011 certificate that will soon be replaced with the Windows UEFI CA 2023 one. So DBX is pretty much the opposite of the DB list, and Secure Boot's job is to make sure any UEFI application that's trying to run on your system is on the DB list, but not on the DBX one. Now, the Microsoft CA 2011 certificate isn't actually used by Microsoft to sign their own UEFI software, but rather it's used by third-party companies like the system recovery tools that I mentioned earlier. If those applications are able to pass Microsoft's internal review of the software, then they'll get signed with that third-party UEFI certificate and be able to pass those secure boot checks on the majority of modern systems. Now, if you visit Microsoft's Hardware Dev Center, they have a post called UEFI Signing Requirements that is supposed to instruct developers of these third-party applications what they need to do in order to get their app signed by Microsoft so that it can actually work on people's computers. But Microsoft doesn't really clarify what their internal review process of these apps looks like, and you'll probably come to the same conclusion that I did after you take a look at the exact cause of this particular vulnerability, that this internal review process is not thorough enough, and it probably needs to be changed a bit to deal with the ever-evolving threat of UEFI malware. Now, when ESET was doing an analysis on Howier's sysreturn software package last year, they discovered a file called cloak.dat that was being deployed alongside the Microsoft-signed Reloader.efi application. Cloak.dat is actually an unsigned UEFI application itself that is encrypted using a fairly simple XOR cipher. The Cloak file can get loaded from a few different locations within your EFI directory. It gets loaded into memory and decrypted. And although this might sound like malicious behavior already, the Cloak file itself is not actually malware, and everything here would be fine as long as the buffer that was containing the decrypted image from cloak.dat were to be passed to the UEFI load image function so that it could be checked normally. But unfortunately, the vulnerable bootloader calls its own function that you can see here, which manually loads and executes the image from the memory buffer without any secure boot integrity checks. So if someone places malicious code into that cloak.dat file, then they can compromise any system that has Microsoft's third-party UEFI certificate enrolled on it. It's also worth mentioning that you don't need to have sysreturn or any of those other vulnerable system maintenance tools installed on your system, because all that's really vulnerable here is the Reloader.efi file. So the attacker can just bring that with them and their own custom cloak.dat file, which they're going to place onto your system anyway in order to compromise it. The only reason that this vulnerability isn't a much bigger deal is because an attacker needs to already have admin or root access to the target device. But since this malware is targeting the firmware of your system, I think it's a much bigger deal because that can be extremely difficult to remove. Like I said, it's able to persist even across operating system resets, which is generally the last-ditch effort that even newbies are going to use to try to fix their computer after it's been compromised. ESET included a proof of concept video demonstrating an attack like this. So here you can see that their testing system is Ubuntu Linux, which is running in VMware. And the person in this video is going to run some commands to show us that they do indeed have secure boot enabled, as you can see there. They're going to show us that their UEFI DB certificates are up to date. And they're also going to show us that the DBX revoked certificates list is up to date as well. So they're showing us their current version is 3.7.1 right there. And they're also going to go online as well to show us the most up-to-date DBX version to doubly prove that his Ubuntu Linux system is up to date. And now I believe he's just going to go ahead and run the install poc.sh, which you can see is basically just defining some variables for his EFI directory and the vulnerable app Reloader.efi and a malicious payload, which is going to be in the cloak.dat file. So his shell script here is basically just copying those files into place, and they'll get executed when the system reboots. And then you can see here that his system is now pwned. But of course, if this were a real hacking scenario, the malware wouldn't be this obvious. It would probably just sit in the background, stealing valuable data, mining crypto, and doing other hard-to-detect nefarious activities. Now, luckily, there are ways to check to see if you're vulnerable to this threat. Simply paste this text into PowerShell on a Windows PC, and it will return true if you have updated DBX signatures to prevent the vulnerable signed software from running. Or you can use DBX tool on Linux to check and see if the relevant hashes are in your DBX list. Make sure your systems are up to date before someone else takes them over. If you enjoyed this video, please like and share it to hack the algorithm, and check out my website based.win, where you can buy my awesome merch and accessories for your phone or laptop. 10% store-wide discount when you pay with Monero XMR at checkout. Have a great rest of your day.